Exercise 14.1, question number 1. Complete the following statements. First one, probability of an event E plus probability of event not E. So here, the happening side plus not happening side will always be 1 here. So here answer will be 1 here. That means a event when you want to happen here, so happening side happening plus not happening will always be 1 here. So the answer will be 1 here. Second one, the probability of an event that cannot happen is such an event is called as. So this we call it as impossible event here. Impossible event here. Impossible event. So that means if a coin is having 2 heads, suppose, then you want tail, then it won't happen here. So that is called as impossible event here. Third one, the probability of an event that is certain to happen, such a event is called as dash. So this we call it as sure event. So this we call it as sure event. Suppose a coin is there here, the coin which is having 2 heads, suppose, both sides 2 heads, then whenever you toss it, you will get head only. So you can't get tail here. So that event is called as sure event here. Next, fourth one, the sum of probabilities of all elementary events of an experiment is dash. So this will be 1 here. So that means happening plus not happening, or whenever you go for elementary events also, the total will be 1 here, always in the probability. Fifth one, the probability of an event is greater than or equal to and less than or equal to. So this will be greater than or equal to or less than or equal to, means here 0 and 1 here. So whenever you go for an event, the probability will be between 0 to 1 only. You can't get less than 0 or more than 1 here. So whenever you go for a problem solution in the probability, you will be seeing your answer between 0 and 1 only. You can't get more than 1 or more than less than 0 here. That means whenever you go for an exam or result here, you will be getting 0 to 100% only. You can't get more than 100% or less than 0%. In the same way, the probability also between 0 to 1 here. Question number 2. Which of the following experiments have equally likely outcomes? Explain. So first, a driver attempts to start a car. The car starts or doesn't start. So here the answer will be, it is not equally likely outcome here. It is not equally likely outcome here. So why here? In the sense, in the most of the cases when you are going to say the car starts here, so the car doesn't start, the chances is very less, and it depends on the factors here, the car condition here. So we can't say the outcome will be equally likely here. So here in this case, it is not equally likely outcome here. Second one, a player attempts to shoot a basketball. She shoots or misses the shot here. So here also the answer will be not equally likely outcome here. So here in a sense, the shot misses or shoots, it depends upon the player ability here. So here the chances are not 50-50 here. So equally likely means 50-50. Third one, a trial is made to answer a true false question, the answer is right or wrong. So here the answer will be equally likely outcome here. So because the chances of getting right or wrong is 50-50 here. So it is not dependent on any factors here. When a trial is made here, okay, so then the true false question, it is right or wrong, it is equally likely outcome here. Next, fourth, a baby is born, it is boy or a girl. So it is also equally likely outcome here. So here it is also not depends on any factors here. So getting a boy or girl, it is neutral here. So the chances will be 50-50 here. So we can't say 100% it is boy or girl here. So the outcome will be equally likely here. Question number 3. Why is tossing a coin considered to be a fair way of deciding that which team should get the ball at the beginning of a football game? So tossing a coin is considered as the best way here. So here, why here in the sense, the outcome will be equally likely here. So here the reason will be equally likely outcome here. So when there is a chances of 50-50, then we can use that to decide about which team should bat or ball here. So coin has a 50-50, no bias in this. So that's why we are going to use coin tossing here. So there is an equal chance of getting a head or tail here. So two possible outcomes we are going to see, which is head or tail, and equal chances we are going to see. So that's why we are going to get equal likely outcome. So we can write equal chance to get a ball, equal chance to get the ball when you toss a coin. So two possible outcomes we are going to see. Two possible outcomes we are going to see, that is head or tail here. So which are equally likely outcome comes here. So this is the reason why we are going to toss a coin in deciding to get a ball or bat here. Question number 4. Which of the following cannot be the probability of an event? A. 2/3, B. -1.5, C. 15%, D. 0.7 here. So we know the probability of an event. So probability of a event, whenever you are going to say, it lies between 0 and 1 here. So whichever probability you are going to take, it lies between 0 and 1 here. So when you are going to take A here, 2/3, so when you are going to divide it, you get 0.666. So here it is between 0 to 1 here. And when you are going to see 15%, so when the 0.6, when it is converted to percentage, then it will be between 0 to 100% here. So your answers will be 0 to 100%. So 15% also lies between 0 to 100. So this is also chances. Next D, when you are going to see 0.7 which lies between 0 to 1 here. So this is also having a probability chance here. So which of the following cannot be the probability here? So cannot be means here B1 when you are going to say it is minus 1.5. Minus sign won't be there between 0 to 1 here. So your answer will be minus 1.5, that is B here. So B minus 1.5 is not probability of an event here. Question number 5. If P of E is equal to 0.05, what is the probability of not E here? So here we know the data given P of E which is 0.05 here, and we know the probability of event and probability of not event is always be equal to 1 here. That means P of E plus P of not E is always equal to 1 here. So P of E is given which is 0.05 plus P of not event, so that is equal to 1. So P of not event so is equal to 1 minus 0.05 here. So that is equal to here 0.95 here. So this is the probability of a not event here. Question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes, first one, an orange flavored candy? So here P of event, when you are going to see P of event, so here orange flavored candy, that means P of event will be favorable ways to get lemon here by to get orange here by favorable ways plus unfavorable ways here. So now our event is orange here, that means P of orange here. Now what is the chances of getting orange here? That means the favorable ways means it will be 0 here. Now denominator favorable ways of getting an orange is 0 and unfavorable ways will be one here. That means not getting orange is 1 here. So that will be 0 by 1, that will be 0 here. So this is called as impossible event, means this event won't happen. So that's why it is a impossible event, because the bag contains lemon flavored candies and the question is asked orange flavored candies, so it won't happen here. So this we call it as impossible event here. Now second, when you are going to say a lemon flavored candy, what is the probability of getting a lemon flavored candy here? So here when you are going to say P of lemon flavored candy will be favorable ways here, favorable ways by favorable ways plus unfavorable ways here. So that will be, so getting lemon, how many chances are there means 1 chance is there. And here denominator 1 chance. Not getting chance will be 0 here. So it will be 1 by 1, that will be 1 here. So this type of event we call it as a sure event. So this type of event we call it as sure event. So the bag contains lemon flavored candies here. And you are asking lemon. So it is called as sure event. Question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that 2 students have the same birthday? So here, the given data P of not having the same birthday means not event is 0.992 here. So here having the birthday will be 1 minus this year. That means when we are going to say you are not going to pass the exam is 20%, not pass 20% suppose, then what is the chance of getting pass? Then 100 minus 20. So 100 minus 20, so that will be 80% chance is there to pass. In the same way, if I say your chance is 70% not pass, then pass will be 100 minus 70, 30 here. So in the same way, in the question they are given not happening the event is 0.992, then happening the event P of E will be X here. And whenever you see P of E plus P of not E means P of happening side plus P of not happening side, not happening the event will always be 1 here. So we know P of E, let X, and here P of not even happening 0.992, so that is equal to 1 here. So X is equal to 1 minus 0.992, so that will be 0.008 here. So the probability that 2 students have the same birthday is 0.008 here. So this is the answer. Question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red here? So first we are going to see red ball here. So first one, red ball, red ball. So what is the probability of getting a red ball here? So they have asked P of red ball here. So P of red ball here means they have asked the question in the happening side. So P of red ball will be favorable ways by favorable ways plus unfavorable ways here. So here when you are going to see in a bag, the chance of getting red ball favorable ways, how many? 3 are there. So 3 will be here. So next denominator, favorable ways, how many are there? 3 are there. Next unfavorable ways, when you see in the ball, the unfavorable ways will be 5 here. That means these are not red balls. So 5 here. So that is equal to 3 by 3 plus 5. So that will be 3 by 8. So that will be equal to 0.375 here. So this is the probability of getting a red ball here. Next second one, when you are going to say not red ball. So not red ball means it is saying not happening side. That is probability of not red ball here. So the formula will be unfavorable ways by favorable ways. Here unfavorable ways plus favorable ways here. So not happening side they ask. So unfavorable ways we are going to see. So which is not red ball. So not red ball in the bag will be, unfavorable ways will be 5 here. That means these 5 are not red balls. Next denominator unfavorable ways 5. Next favorable ways in a bag how many are there? 3 are there. So 3. So 5 by 5 plus 3. So that will be 5 by 8 here. So 5 by 8 will be 0.625 here. So this is a probability of not getting a red ball here. Question number 9. A box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be a red ball, white ball, not a green ball? So here first one, when you are going to see red ball, probability of getting a red marble here. So the question is asked in the happening side. That means P of red ball, red marble. So that will be favorable ways, favorable ways by favorable ways plus unfavorable ways here. So getting a red ball from the bag. So how many red balls are there? 5 are there. Next favorable ways will be 5 here. Unfavorable ways. So not getting the red ball. So that will be 8 plus 4. So here 8 plus 4 here. So we get 5 by 17 here. So this is the probability of getting a red marble here. Next when you are going to see second one, white ball. What is the probability of getting a white marble here? So P of white marble. So when you are going to see happening side, the question is asked. So favorable ways by favorable ways plus unfavorable ways here. So what is the chance of getting the white ball here? That means 8 here. And denominator favorable ways 8 here. Not getting the white ball, that will be 5 plus 4 here. 5 plus 4 will be 9 here. So that is equal to 8 by 8 plus 9, which will be 17 here. So this will be probability of a white ball here. Now third one, when you are going to say P of not green. P of not green. Probability of not green. So the question is asked here in the sense not happening side. The formula will be unfavorable ways, unfavorable ways by unfavorable plus favorable ways here. So not getting green. So not getting green. Green how many are there? 4 are there. Not getting means 5 plus 8 here. So that will be 13 here. So now denominator unfavorable ways will be 13 here. So favorable ways getting green will be 4 here. So that will be 13 by 13 plus 4, which is 17 here. So probability of not getting green will be 13 by 17 here. Question number 10. A piggy bank contains 150 paisa coins, 50 rupees 1 coins, 22 rupees coins and 10 5 rupee coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin first will be a 50 paisa coin, second will not be a 5 rupees coin? So here a kitty bank, a bank is there which is containing 50 paisa coins, 50 paisa, rupees 1 and rupees 2 and here rupees 5 here. So rupees 50 paisa or 100 here, rupees 1 50, 2 rupees 20 and 5 rupees 10 it is. Now they have asked what is the probability that the coin when it is turned upside down will be getting a 50 paisa coin here. So here question is asked in the happening side. That means P of 50 paisa coin here. So happening side they asked, that means favorable ways by favorable ways plus unfavorable ways here. So now getting a 50 paisa coin, favorable ways how many are there? 100 are there. So here 100 favorable ways are there to get a 50 paisa coin here. Next denominator, favorable ways how many are there? 100 are there, plus unfavorable ways how many are there? So where you can't get 50 paisa coin here. That means 50 plus 20 plus 10 here. So that will be 50 plus 20 plus 10 here. So that will be 100 by 100 plus 80. So that will be 100 by 80. So that will be 5 by 9 here. So this is the probability of getting 50 paisa coin here. So second, what is the probability that the coin will not be 5 rupees coin here? So here they have asked in not happening side here, P of not rupees 5 rupees coin here. So that will be formula unfavorable ways by unfavorable ways plus favorable ways here. So not getting rupees 5, unfavorable ways how many are? 5 rupees coins are 10 here. So not getting 5 rupees coin will be 100 plus 50 plus 20. So this is means 50 paisa 100 coins, 1 rupee 150 coins, 2 rupees 20 coins. These are the unfavorable ways here. Next denominator, when you are going to see unfavorable ways how many are there? So this is only 100 plus 50 plus 20 here, plus now favorable ways getting rupees 5 how many are there? So 10 coins are there. So here 10 here. So when you simplify here, 100 plus 50 plus 20, that will be 170, and 170 plus 10 will be 180 here. So that will be 17 by 18 here. So this is the probability that a coin will not get a 5 rupees coin here. Question number 11. Gopi buys a fish from a shop for his aquarium The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish here? So here an aquarium is there. So in this aquarium we are going to see 5 male fish and 8 female fish here. So in the question they asked what is the probability that it should be male fish here. So here the question is asked in the happening side. That means P of male fish. P of male fish. So that will be question asked in the happening side. Then that will formula will be favorable ways by favorable ways plus unfavorable ways here. So when you are going to see this tank, getting a male fish chances how many are there? 5 are there. So this will be 5 here. Next denominator, getting the male fish 5 are there plus. Now unfavorable ways, not getting the male fish how many are there? 8 are there. So this will be 8. So that will be 5 by 13 here. 5 by 13 here. So the probability of the fish taken out is a male fish is 5 by 13 here. Question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. And these are equally likely outcomes. What is the probability that it will point at 1, 8 here? So here the question asked in the happening side. So P of 8, so that will be favorable ways by favorable ways plus unfavorable ways here. So what is the probability that it will point at 8? So what are the chances to get 8 here? So 8 number is 1 only. So we are going to say 1 chance is there. Next denominator, favorable ways how many are there? 1 is there. Unfavorable ways how many are there? That means not getting 8, 7 are there. So 1 by 1 plus 7. So that will be 1 by 8 here. So the probability that it will point at 8 is 1 by 8 here. Next second, what is the probability that it will point at odd number? So asked in the happening side, that means P of odd number, P of odd number. So that will be equal to favorable ways by favorable ways plus unfavorable ways here. So getting an odd number. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8 are there. So odd numbers how many are there? 1, 2, 3, 4. So 4 are there. Favorable ways are 4 here. Next denominator, favorable ways are 4. Unfavorable ways, not getting odd number, which is not odd number, how many are there? 1, 2, 3, 4. So 4 are there. So that means 4 by 8. So that is equal to 1 by 2 here. So the probability of an odd number is 1 by 2 here. Next third one, what is the probability that it will point at a number greater than 2 here? So happening side they asked P of greater than 2 here. So greater than 2. So formula will be favorable ways by favorable ways plus unfavorable ways here. So we have the numbers 1, 2, 3, 4, 5, 6, 7, 8. So what is the probability that it will point greater than 2? So greater than 2, how many are there? 1, 2, 3, 4, 5, 6 are there. So number of favorable ways will be 6 here. So denominator favorable ways will be 6. Unfavorable ways not getting greater than 2, how many are there? 2 are there. So that means 2 is. So 6 by 6 plus 2, that will be 6 by 8 here. So that is equal to 3 by 4 here. 3 by 4. So next fourth one, the probability that it will point at a number less than 9 here. So less than 9. So probability less than 9. So that is equal to favorable ways by favorable ways plus unfavorable ways here. So we have the number 1 to 8 here. So less than 9, how many are there favorable ways? 8 are there. So 8 favorable ways are there. So denominator favorable ways will be 8 here. So unfavorable ways less than 9, how many unfavorable ways are there? That will be 0 here. So that is equal to 8 by 8. So that is equal to 1 here. So the probability of that it will point at number less than 9 is 1 here. Question number 13. A die is thrown once. Find the probability of getting a prime number here. So here we know numbers in the die, that is 1, 2, 3, 4, 5, 6. So here they asked in the happening side probability of getting the prime number. So P of prime number. P of prime number. So here favorable ways by favorable ways plus unfavorable ways here. So here prime number, how many are there? So 2, 3, 5. So these three numbers are prime numbers. So getting a prime number, how many chances are there? 1, 2, 3 are there. So favorable ways will be 3 here. So denominator favorable ways 3. Unfavorable ways, how many are there? 1, 2, 3. So here 3 are there. So that means 3 by 6. So that is equal to 1 by 2 here. So the probability of getting a prime number is 1 by 2 here. Next, second, probability of a number lying between 2 to 6 here. So here 2 to 6, how many numbers are there? That means here 1, 2, 3, 4, 5, 6. So here happening side P of between 2 and 6 here. So that will be favorable ways by favorable ways plus unfavorable ways here. So between 2 and 5, how many are there? 3 are there. So favorable ways will be 3 here. So by 3 plus unfavorable ways, how many are there? Between 2 and 6, 3 are there. So that will be 3. So 3 by 3 plus 3, that will be 3 by 6. So that is equal to 1 by 2 here. Next, third, the probability of getting an odd number. So odd number, when you are going to say 1, 2, 3, 4, 5, 6. So here P of odd number, when you are going to say favorable ways by favorable ways plus unfavorable ways. So that is equal to, so getting an odd number, here 1, 2, 3. So 3 are there here. So 3 by favorable ways 3. Unfavorable ways, how many are there? 3 are there. So that will be 3 by 6. So that is equal to 1 by 2 here. Question number 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color here. So here question asked in the happening side, P of king of red color here. So that will be favorable ways by favorable ways plus unfavorable ways here. So that will be, so card, how many red color kings will be there? 2 are there. One will be diamond and one will be heart. So here 2 will be there. So favorable ways will be 2 here, and unfavorable ways how many will be there? 50 will be there. So that will be 2 by 2 plus 50. So that will be 2 by 52. So that will be 1 by 26. So the probability of a king of red color will be 1 by 26 here. Next, probability of a face card. Face card, how many will be there? So probability of face card. Probability of face card. So here favorable ways by favorable ways plus unfavorable ways here. So face cards, how many will be there? One is J, Q, K. So here 3 times, 4 times it will repeat. That means 3 into 4. That will be 12 you are going to see. 3 into 4, 12 face cards you are going to see. So favorable ways will be 12 here. So denominator 12 plus unfavorable ways, how many will be there? 40 it will be there. So that will be 12 by 12 plus 40, which is 52. So that is equal to 3 by 13 here. So this is the probability of face cards. Next, probability of a red face card. Red face card, how many will be there? One will be a face card which will be J, Q, K are there, and red color will be one diamond will be there and other heart shape will be there. So total you are going to see here 3 and into 2, that means 6 you are going to see. So probability of red face card, so that will be favorable ways by favorable ways plus unfavorable ways here. So that is equal to favorable ways, how many will be there? 6 by 6 plus unfavorable ways, how many will be there? 46. So that will be 6 by 6 plus 46, that will be 52. So that is equal to 3 by 26 here. Next, fourth, the jack of hearts here. So jack of hearts, probability of jack of hearts. So that is equal to favorable ways by favorable ways plus unfavorable ways. So that is equal to jack you are going to see and a heart shape you are going to see. So how many cards you are going to see? Means only one card you are going to see. Favorable ways will be 1. So here 1 plus unfavorable ways, how many it will be? 51. So that is equal to 1 by 52. Next, fifth one, probability of a spade here. So P of spade here. So that will be favorable ways by favorable ways plus unfavorable ways here. So spade, when you are going to see, how many will be there? Spade. So this is a spade here. So how many it will be there? Means in a deck 13 will be there. So here 13. So favorable ways will be 13. Unfavorable ways, how many will be there means 39 it will be there. So that will be 13 by 13 plus 39, which will be 52. So that will be 1 by 4. So probability of spade will be 1 by 4 here. Next, sixth, probability of the queen of diamonds. So probability of queen of diamonds. So that will be favorable ways by favorable ways plus unfavorable ways here. So queen and diamond shape. How many it will be there means only 1 will be there. So 1 by favorable ways 1 plus unfavorable ways will be 51 here. So that will be 1 by 52 here. So this is the probability of a queen of diamond here. Question number 15. 5 cards, the 10, Jack, Queen, King and Ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is the Queen here? So here they have asked in the happening side P of Queen here, P of Queen here. So P of Queen probability, that means favorable ways by favorable ways plus unfavorable ways here. So 5 cards have been shuffled, means one is 10, Jack, Queen, King, Ace. So here what is the favorable ways of getting Queen here means 1 here. So 1 we are going to see favorable ways. Next, favorable ways in the denominator 1 plus unfavorable ways where you can't see Queen. How many are there? 1, 2, 3, 4 are there. So 4 will be there. So that will be 1 by 5 here. So the probability of the card is Queen is 1 by 5 here. Next, second, if the Queen is drawn and put aside, what is the probability that the second card picked up is an Ace and a Queen here? So we have 5 cards, 10, Jack, Queen, King, Ace here. So one card is kept aside. What? Queen here. So this is kept aside. So now we are going to see what is the probability of an Ace here. So probability of Ace here. So that will be favorable ways by favorable ways plus unfavorable ways. So that is equal to favorable ways. How many are there? To get a Ace, 1 are there. So 1 is there. Now here favorable ways 1 is there. Unfavorable ways how many are there? So here Queen is not there. So 1, 2, 3 are there. So total 3 are there. Unfavorable ways. So that will be 1 by 1 plus 3, which is 4 here. Next, second, probability that Queen. So P of Queen when you are going to see. So here favorable ways by favorable ways plus unfavorable ways here. So now Queen is not there in this deck. So they are asking probability of Queen. What is the chance of second card, whether it is a Queen or not here. So here Queen, getting a Queen is 0 here. Favorable ways is 0. Next, denominator favorable ways is 0 and unfavorable ways how many are there? 1, 2, 3, 4. 4. So not getting the Queen, how many are there? 4 ways are there. That is equal to 0 by 0. It will be 0 here. So 0 by 4 it will be 0 here. So probability of Queen is 0 here. Question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So here defective pens are 12 here. Good ones are 132 here. So they are mixed here, and here one pen is taken at random here. So here in the question they are asking what is the probability that it is a good one. So P of a good one we are going to see. So here the question is asked in the happening side. So here favorable ways by favorable ways plus unfavorable ways here. So what is the chance of getting a good one means 132 chances are there. So 132 chances are there. These are the favorable ways. By favorable ways 132 chances are there. Unfavorable how many chances are there? That means 12 are there. This is a 12 unfavorable chances. So that will be 132 by 132 plus 12, which will be 144. So upon simplification we get 11 by 12 here. So this is the probability of the good one. Question number 17. First one. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So here defective bulbs, defective ones, how many are there? 4 are there. Which are not defective, how many are there? Total is 20 minus 4, so that will be 16 here. So in the question they asked the probability of the bulb which is defective. That means happening side they asked P of defective. So that will be favorable ways by favorable ways plus unfavorable ways here. So favorable ways defective, how many are there? 4. So favorable ways will be 4. Unfavorable ways, how many are there? Means which is not defective, that will be 16. So that is equal to 4 by 16 plus 4, that will be 20. So that will be 1 by 5 here. So probability of defective will be 1 by 5 here. Next, second, suppose the bulb drawn in 1 is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? So here not happening side they asked not defective, which is not probability of not defective you are going to see. That means unfavorable ways by unfavorable ways plus favorable ways here. So here probability of not defective, unfavorable ways. So how many not defective are there? Here 16 are there. Next they asked the bulb is drawn but it is not replaced. So one is drawn here, not replaced. Now unfavorable ways how many will be there? Means 15 are there. 15 are there. So next favorable ways which are defective how many are there? Here 4 are there. So here 15 means here 16 minus 1 which is not replaced here. So now 16 by 15 plus 4 which will be 19 here. So the probability of not defective will be 16 by 19 here. Question number 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number here. So probability of a 2-digit number we are going to see. So probability of a 2-digit number. So the question asked in the happening side, that means favorable ways by favorable ways plus unfavorable ways here. So here two digit numbers, how many are there means here 10 to 90 we are going to see. So that will be 81. And 1-digit number we are going to see 1 to 9. So that will be 9 here. So 2-digit number favorable ways how many are there means 81 are there. 81. So favorable ways 81 plus unfavorable ways how many are there means 9 are there here. So 81 by here 90. So upon simplification here 9 by 10 here. So this is the probability of a 2-digit number here. Next, probability of a perfect square number. So from 1 to 90, so perfect square numbers, how many are there we are going to see. So here probability of a perfect square number. So that will be favorable ways by favorable ways plus unfavorable ways here. So that will be, so perfect square numbers will be 1 to 9 here. 1 square 1, 2 square 4, 3 square 9, 4 square 16 up to 9 square 81 here. So total 9 will be there. So favorable ways will be 9 here. So favorable ways here 9 plus unfavorable ways how many will be there means here 81 will be there. So that will be 9 by 90. So that will be 1 by 10 here. So this is the probability of perfect square number. Next third, the probability of the number divisible by 5 here. So probability number divisible by 5 here. So that will be here happening side they asked favorable ways by favorable ways plus unfavorable ways here. So which is divisible by 5 here. So total 90 are there, 90 by 5. So that will be 18 numbers you are going to say which are divisible by 5 here. So number of favorable ways will be 18 here, 18 here. So favorable ways will be 18. Unfavorable ways how many will be there means which are not divisible by 5, that will be 72. So that is equal to 18 by 90. So that will be 1 by 5 here. So this is the probability of the number divisible by 5. Question number 19. A child has a die whose 6 faces show the letters as given below. A, B, C, D, E, A. The die is thrown once. What is the probability of getting one A to D here? So first one, probability of getting A. So P of A, that means happening side they ask, which is favorable ways by favorable ways plus unfavorable ways here. So that will be, so getting A on the die once it is thrown, how many favorable ways are there means 1, 2. So 2 chances are there. So 2 by, so favorable ways will be 2 plus unfavorable ways how many are there? 1, 2, 3, 4. So 4 are there here. So that will be 2 by 6. So that will be 1 by 3 here. So probability of A here. Now probability of D when you are going to see. So happening side they asked favorable ways by favorable ways plus unfavorable ways here. So getting D, how many chances are there? One chance is there. So one chance favorable ways. So here 1 plus unfavorable ways, how many are there? 1, 2, 3, 4, 5 are there. So that means 5 here. So that is equal to 1 by 6 here. So probability of getting D is 1 by 6 here. Question number 20. Suppose you drop a die at random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with a diameter 1 meter here? So here the rectangle is given which length 3 and breadth 2, and circle whose diameter is also given. This diameter is 1 meter here. So now when a die is thrown, what is the probability that it land inside the circle here? So first we are going to find the area of rectangle and area of circle here, and then we are going to apply in the probability problem here. Now area of rectangle, when you are going to see area of rectangle, so that will be L into B here. So that will be 3 into 2 here. So 3 into 2. So that will be 6 meters square here. Next, area of circle we are going to see. Area of circle. Area of circle. So area of circle, how much? Pi r square here. So D is 1 meter here. So R will be 1 by 2 here. So that will be 1 by 2 whole square. So that will be pi by 4 here. So this is the area of circle. Now we are going for probability of landing inside the circle. Probability inside the circle here. So that will be what is the probability inside the circle happening side. That means favorable ways by favorable ways plus unfavorable ways here. So that will be, so inside the circle favorable ways will be pi by 4. This much area chance are there. So pi by 4 here. By favorable ways will be pi by 4 plus unfavorable ways means this part. So total this part. That means rectangle minus area of circle here. That will be 6 minus pi by 4 here. So here pi by 4 cancel. We get here pi by 4 by 6 here. So that is equal to pi by 4 plus pi by 4 into 1 by 6. That is equal to pi by 24 here. So this is the probability that the die land inside the circle here. Question number 21. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy and she will not buy here? So here defective, how many are there? So defective pens 20 are there. So not defective will be total 144 minus 20. So that will be 124 not defective pens are there here. Now first one, what is the probability she will buy? So probability Nuri will buy here. So happening side they asked favorable ways by favorable ways plus unfavorable ways here. So here favorable ways means when it is not defective she will buy. That means number of unfavorable ways of pens which are not defective, how many are there? That means 124 are there. So here favorable ways will be 124. Unfavorable ways where she can't buy here, that means which are defective, that means 20 here. So 124 by 144 here. So upon simplification we get 31 by 36 here. So this is the probability that Nuri will buy here. Second, she will not buy it. That means probability not buy here means the question is asked in the not happening side. That means unfavorable ways by here unfavorable ways plus favorable ways here. So unfavorable ways means not buy. Unfavorable ways how many are there means 20 are there where she can't buy here. So unfavorable ways 20 plus favorable ways how many are there means 124 are there. So that will be 20 by 144. So after simplification we get here 5 by 36 here. So this is the where she can't, this is the probability where she won't buy the pen here. Question number 22. Refer to example 13. First, complete the following table. Event sum of two die is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The probability is 1 by 36. Here blank. 5 by 36. Here 1 by 36. So here first we are going to see the probability of 3 here. So here first one probability of 3 here. So here they are given the sum of two die. So how you are going to get 3 here in the sense the chances are 1 and 2 here. So this is the first chance means 1 plus 2 will be 3 here. Next 2 comma 1 here. So this is also possibility here. So now we are going to see the probability of 3 happening side favorable ways. That means 2 favorable ways we are going to see by 2 plus unfavorable ways will be 34 here, because die when you are going to see the unfavorable ways will be 34. So total will be 36 here. So here 2 by 2 plus 34. So that will be 2 by 36. So that will be 1 by 18 here. So next when you are going to see probability of 4 here. So when two dice are sum, when you are going to do, you should get 4 here. So the probability will be 2 comma 2 here, one option. Next 1 comma 3. Next 3 comma 1 here. So 2 plus 2, 1 plus 3, 3 plus 1. So we have 3 favorable ways here. So now P of 4 will be favorable ways will be 4 here. Now favorable ways 4 plus unfavorable ways will be 32 here. So that will be 4 by 36. So that will be 1 by, so here 3 here. So 3 ways are there. So here 3. So here 3. Here 33. We get 36. 1 by 30. 3 by 36. So that will be 1 by 12 here. Next third probability of 5 here. So 5 sum, how you are going to get? 1, 4 we are going to see one possibility. Next 4, 1 we are going to see. Next 2, 3 we are going to see. Next 3, 2 we are going to see. So the sum will be 5 here. So the favorable ways will be 4 here. So P of 5 will be favorable ways 4 by 4 plus 32. So that will be 4 by 36 here. So that will be 1 by 9 here. So next when you are going to see probability of 6 here. So 6, how you are going to get? First 1 comma 5 here. Next 5 comma 1 here. Next 2, 4 when you are going to add. Next 4 and 2. Next 3, 3 here. So these are the possible outcomes. So now the favorable ways are 5 here. So 5 by 5 plus unfavorable ways 31. So that is equal to 5 by 36. So P of 6 is 5 by 36 probability. Next fifth, P of 7 when you are going to see. So that will be 1, 6, 1 comma 6, 6 and 1 we are going to see. Next 2, 5 we are going to see. Next 5, 2 we are going to see. Next 3, 4 we are going to see. Next 4, 3 we are going to see. So total outcomes are 6. So 6 by 6 plus 30 here. So that will be 6 by 36. So that will be 1 by 6 here. So next we are going to see P of 9 here. So P of 9 when you are going to see 3 comma 6. Next 6 comma 3. 4 comma 5. Next 5 comma 4 here. So when you add two numbers you will get 9 here. So 4 outcomes are there. So favorable ways are 4 here, 4 plus here, unfavorable ways 32 here. So that will be 4 by 36. So that will be 1 by 9 here. So next we are going to see P of probability of 10 here. So we get 1, 4 and 6 here, 6 and 4 here. Next 5 and 5 we are going to see. So here 3 outcomes you are going to see. So favorable ways will be 3 here. So 3 plus 33 here. So that will be 3 by 36. So that will be 1 by 12 here. Next P of 11 we are going to see. So 5 and 6. Next 6 and 5. So there are 2 outcomes. So favorable ways will be 2. 2 plus 34 here. So that is equal to 2 by 36. So that will be 1 by 18 here. So our answers will be the sum of 2 die of 3 will be 2 by 36. Next 4, 3 by 36. For 5, 4 by 36. For 6, 5 by 36. For 7, 6 by 36. For 9, 4 by 36. For 10, 3 by 36. For 11, 2 by 36 here. So these are the probabilities here. Next, second, a student argues that there are 11 possible outcomes 2, 3, 4, 5, 6, 7, 8, 9, 10 and 12. Therefore, each of them has a probability of 1 by 11. Do you agree with this argument? Justify your answer. So, the answer will be no here. So, it is not like that possible outcomes are 11. We are going to see the probability 1 by 11. So, because the sum is because the probability is not equally likely here. The sum of 11 doesn't have, the sum of 11 are not equally likely here. So, no, the sum of 11 are not equally likely here. So, this is the answer. Question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Arif wins if all the tosses give the same result, 3 heads or 3 tails, and loses otherwise. Calculate the probability that Arif will lose the game here. So here, first we are going to see Arif 3 times he is going to toss the 1 rupee coin here. First we are going to see the total outcomes here. So total outcomes we are going to see. So 1, 2, 3 here. So first time, second time, third time. So first time when he is going to toss, the probability of getting head, suppose head, head, head. This is the first output. Next, when you are going to say head, tail, tail here. Next, tail, tail, head here. Next, tail, head, tail here. Next, tail, tail, head here. Next, head, tail, head here. Next, head, head, tail here. Next, tail, tail, tail here. So these are the outcomes. So first time when you are going to say first time, second time, third time, outcomes are there. So now we are going to calculate the probability of Arif will lose the game here. So lose the game means probability of lose here. Probability of lose the game here. So that will be favorable ways by favorable ways plus unfavorable ways here. So when he will lose the game, when the outcomes are not 3 heads, not 3 tails here. So 3 heads, 3 tails, only one time you are going to see here. So the rest are the outcomes which doesn't have 3 heads and 3 tails here. So how many outcomes are there means 1, 2, 3, 4, 5, 6 are there. So chances of losing the game, that means favorable ways will be 6 here. Now favorable ways are 6 plus unfavorable ways. Unfavorable ways will be 1 and 2 here. This is 3 heads and 3 tails. So here 2 here. So that will be 6 by 8 here. So 6 by 8, that will be 3 by 4 here. So 3 by 4 means probability of losing the game is 3 by 4 here. Question number 24. A die is thrown twice. What is the probability that 5 will not come up either time? Second, 5 will come at least once. So here die is thrown 2 times. So here we are going to check the number 5 will not come and will come here. So first we are going to see the outcomes of 2 dice here. Then we are going to find out the probability. So here when you are going to see die here, so die 1, die 2 when you are going to see. So die has 6 numbers 1, 2, 3, 4, 5, 6 here, and here also 1, 2, 3, 4, 5, 6 here. So now when you are going to see the outcomes, so first will be 1 and 1, next 1 and 2, next 1 and 3, next 1 and 4, next 1 and 5, next 1 and 6 here. In the same way we are going to see here 2 and 1, here 3 and 1, here 4 and 1, here 5 and 1, here 6 and 1 here. So in the same way we are going to write all. So 5 number we are going to see, concentrating on 5 number, 2 and 5 here, here 3 and 5, here 4 and 5, here 5 and 5, here 6 and 5 here. So here also we are going to see 1 here, here also 5 and 6 output, here 5, 2, here 5 and 3, here 5 and 4 here. So now these are the outputs of 5 here. So total outputs are 36 here. The first question they are asked, 5 will not come up either term. So probability of 5 not come up here. So not happening side they are asking, that means unfavorable ways by unfavorable ways plus favorable ways here. So not come up, how many are there? So when you are going to count how many are there, we will get 25 are there. So here without 5 how many are there? 25 are there. Now next unfavorable ways 25 are there. Now favorable ways with 5 how many are there? That will be 11 here. So your 25 by 25 plus 11, that will be 36 here. So this is the probability of 5 not come up here. Next question what they are asking, 5 will come up. That means probability of 5 come up here. So here they asked happening side, that means favorable ways by favorable ways plus unfavorable ways here. So that will be favorable ways. How many are there with 5 up means here 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4, 5, 6 here, here 5 here, and here 6 here. So total we are going to say 11 here. So 11 by favorable ways 11 are there plus unfavorable ways how many are there without 5, that will be 25 here. So 11 by 11 plus 25, which is 36. So 5 coming up probability will be 11 by 36. 5 not come probability will be 25 by 36 here. Question number 25. Which of the following arguments are correct and which are not correct? Give reasons for your answers. First question, if 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3 here. So here the probability is 1 by 3 they are saying. So we are going to check whether it is correct or not. So when you are going to see the outcomes, 2 coins when they are tossed, so outcomes will be head, head. This is one outcome. Next tail, tail, this is another outcome. Next head, tail, another outcome. Next tail and head, this is the another outcome. So there are 4 outcomes you are going to see here. If they have asked find the probability of getting 2 heads, so P of 2 heads when you are going to see, that will be favorable ways by favorable ways plus unfavorable ways. So that will be how many 2 heads are there means 1 by 1 plus unfavorable ways will be 3 here. So that will be 1 by 4 here. If they have asked 2 tails when you want to take the probability, then same favorable ways by favorable ways, unfavorable ways we are going to find out. So then it will be 1 by how many 2 tails are there? 1 only. So 1 by 1 plus 3 here. So that will be 1 by 4 here. If you want to check one of each, then P of either head or tail, then favorable ways will be 2 here. So this is 1, this is 2. So 2 favorable ways by 2 plus unfavorable ways 2. So that will be 2 by 4. So that will be 1 by 2 here. So when they asked 2 heads 1 by 4 probability we are getting, 2 tails 1 by 4 we are getting, and either of them then 1 by 2 probability we are getting. So they told 1 by 3 probability, which is incorrect here. So therefore it is incorrect. Next, second, if a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2 here. So here we know when a die is thrown, we are going to see 1, 2, 3, 4, 5 and 6. These are the outcomes. So P of odd, that is probability of odd when you are going to see, that will be favorable ways by favorable ways plus unfavorable ways. So that will be, so how many odd numbers we can see? 1, 2, 3. So 3 favorable ways are there. 3 chances are there here. So 3 plus unfavorable ways means no chance. How many are there? 3 are there. So 3 by 3 plus 3. So that will be 3 by 6. That is equal to 1 by 2 here. In the same way, when you are going to see even number, probability of even number, so favorable ways by favorable ways plus unfavorable ways. So that is equal to how many even numbers we are going to see? Chances 3 are there. Next 3 plus here 3 are there. So that will be 3 by 6. That will be 1 by 2 here. So here in the question they told the probability of getting an odd number is 1 by 2, which is correct here. So therefore the probability of getting the odd number is correct, and we can say it is equally likely outcomes here.